So good day everyone. I good before, and now we are going to discuss the ending parallel subtractor. What is ending parallel subtractor? Subtractor. An ending parallel subtractor is a digital circuit that performs subtraction on binary numbers in parallel fashion, considering its bit positions simultaneously. It subtracts corresponding bits of two ending binary numbers and produces the result along with bar output. This type of binary subtraction operations use ND, providing a fast and parallel computation of the difference between two binary values. So basically, the ND parallel subtractor can be carried out by taking one or two complement of the number to be subtracted. For example, we can perform the subtraction A minus B by adding either 1 to 1 complement or 2 complement of B to A. That means we can use a binary adder to perform binary subtraction. So later, ipapakita ko sa inyo kung paano nakakuha yung 2 complement na ND para subtraction. So,
Yeah. Uh, Additional description about n-bit parallel subtractor. When we say n-bit parallel subtractor, to explain kung ano nga ba yung n-bit parallel subtractor, ito ay para siyang isa siyang digital calculator na nagsasubtract ng binary numbers sa mabilis na process. So it look like imagine each digit ng kumbaga na-process niya ito ng sabay-sabay. Tapos then sinasubtract nila by kumbaga sabay-sabay niya nasasubtract yung mismong value, and then it gives you the immediate answer doon sa mismong what you call this the two values, between the two values. So n-bit parallel subtractor is good at doing things quickly, especially pag may binary numbers na ang value is n digits. So when we say n-bit, in simple words, it refers to the number of bits na nako-collect natin, which are the smallest units of digital information in binary code po. So para kung nagka-count ng maraming off and on switches or yung tinatawag natin na bits. Tapos yung bits are used to represent information in a computer, with an n being a what you call this placeholder for a specific number, such as 8-bit or 16-bit. Yan. So I'm going to explain to you the four main processes in n-bit. So there I have a notes here. So the first one is n-bit binary A and n-bit binary B. When we say n-bit binary A and n-bit binary B, siya yung kino-consider natin as the values, like kunwari, magsasubtract tayo ng two values, which is the number n-bit binary A and the n-bit binary B. Then next is subtractor logic. This is what we call the brain of our subtraction operation. Kumbaga siya yung process dun sa each pair of corresponding switches ni numbers A and B and figures but the difference between them. Then third one is the result or the difference. The result is where the answers or the difference for each pair of switches are collected. And lastly, what we call the borrow. Borrow, kumbaga if any lang siya. Sometimes when you subtract, you might need to borrow from the next bit, or this part keeps track of any borrowing that happens. Yan. So I'm going to explain to you what the truth table of n-bit parallel subtractor. This table continues for all possible combinations of 3-bit binary numbers A and B. Yan. The difference between column represents result of subtracting B from A. The borrow column indicates whether the borrowing occurred during subtraction. So ang ginawa naming example about sa truth table natin is by 3-bit. Yan. So starting dyan, kunwari Sa 3-bit na yan, there's A, B, and C. Then, yung nasa dulong part, which is yung fourth one, is what we call the barrows. Next, block diagram. Yan. To explain the block diagram, yung nakikita nyo dyang may triangle, ay start tayo dito sa B1, A1, A2, B2, A3, B3. So, yan yung tinatawag nating inputs. When we say, ay pag may nakita kayong triangle shape dyan, na nakalagay dun sa inputs, ibig sabihin inverted siya. So, yung process niya is, yan, bababa siya dun sa full adder 1, and then magpa-process siya dun sa C2, full adder 2, C3, yan. And then yung value na nasa baba, yung S3, S2, and S1, yan yung tinatawag natin na output, or yung final answer, or yung result, o kaya difference na tinatawag. Yung sa part naman ng B n minus 1, A n minus 1, or yung full adder n minus 1, dyan naman siya nagpa-process yung ating n-bit parallel subtractor. Then lastly, yung carry out, yung C out na yan yung meaning niya is carry out. So, I will give you an example. So, meron tayong A value and B value. Okay lang, medyo magulo. Yan. Sa A value natin, kunin natin si 0, 1, 0, 0. And then sa B value naman natin is kukunin natin si 1, 1, 1, 1. Yan. Pag pre-process natin siya doon sa mismong n-bit parallel subtractor, it looks like this. Am I right? Yes. So, dito na papasok yun. Kita ba?
Kita.
Yan. So, dito na papasok yung function ng normal na binary subtraction, which is 1 minus 0 is 1. 1 minus 0 is 1. Then, 1 minus 1 is 0. Then, 1 minus 0 is 1. So, yung ang ating n-bit parallel subtractor value is 1, 0, 1, 1. Or siya yung tinatawag natin na difference or yung result na nakita natin sa process ng n-bit parallel subtractor. Next.
So, now, ipapakita ko sa inyo kung paano kukunin yung this complement para dun sa n-bit parallel subtractor. First, may example tayo na A1, 0, 0, 1. So, para makuha yung 2's complement, first, kunin muna natin yung 1's complement ng babalik, i-invert lang natin siya. So, yung B, diba, 0, 1, 0, 1. So, magiging 1, 0, 1, 0. Ayan yung 1's complement ng B. So, para makuha yung 2's complement ng B, mag-add lang tayo ng 1. Ayan. So, 0 plus 1, 0, 1. Ito na yung 2's complement ng B. Ayan. And then, after nyan, i-add na natin yung value ng A. 1, 0, 0, 1, 0, 0, 1. Ayun. Add lang natin. 1 plus 1 equals 0, carry 1. 0, carry 1, 1. 0, carry 1. Baba lang natin siya. So, kapag ipa-plot naman natin siya sa block diagram, ganito siya. That's 8.
That's good.
That's 8. Ayan, yung ibig sabihin ng SA ay yung full adder. So, dito, ito yung invert side, at ito yung, mix natin. So, So, yung kukunin natin dito ay yung inverted na B. Dito natin ilalagay sa right side ng block diagram. Zero, one. Ay, hindi. Ito pala yun yung inverted. Yung dito natin ilalagay sa left, rather. Yan. And then yung A dito sa right. 1 1 0 0 1. So, ito yung here in 1. Okay. So, 1 plus 1 equals 0, carry 1 siya. Dito ilalagay yung carry sa gilid. And then, 1 plus 1 equals 0, carry 1 then. And then, 0 plus 0 equals 0, 0 plus 1 equals 1. 0 na yung carry kasi wala siya. Wala si carry. And then, 1 plus 1 equals 0, carry 1. And dito yung sum. And then, ito yung carry out. So, bali, yung magiging sagot niya ay 1, 0, 1, 1, 0, 1, 0, 0. So, nakuha natin yung sagot dito. Tapos dito sa pag-plot ng diagram, same lang yung sagot. So, ayun lang yung pag-plot ng Bit Parallel Subtractor sa block diagram.
So here we have the Tinkercad for our breadboard, which represents Bit Parallel Subtraction. So first we will start the simulation, and then as you can see, this bulb is lighting up. So first, let us explain the wires. Yung red wire is yung power. Tama. Red is power. Green is yung negative, yung ground. And then, yung blue is yung B. And then light blue is inverted B. Purple is the A. And orange is S, which is the sum of output. And then, nakakonect sila lahat sa LED. So, yung pink is carry in and carry out. So, na-start na natin yung simulation. And then, for yung nakikita natin ngayon is 111 and 111. So, naka-open to yung ating carry in, carry out. So, ito, ibig sabihin nito, gumagana yung Bit Parallel Subtractor. So, dahil 111 lahat to, naka-binary, which is 1111 minus 1111. So, 0 lalabas. So, walang nagla-light up na LED. And then, pag tinanggal naman natin yung isa dito, which is 1111 minus 1111 lang. And then, ganun din yung sa iba. So, ano dito ang demonstration sa screen, which will visualize it better. Pero, technically, pag yung light bulb hindi naka-open, ay ibig sabihin, hindi siya nagma-minus ng maayos. So, yung carry in, carry out, yung nagdetermine dito sa breadboard kung gumagana ba ang pag-transfer ng yung pag-subtractor natin. So, yung breadboard na to is, ginagamit namin is 4-bit. So, as you can see, 1, 2, 3, 4. 1, 2, 3, 4. Pero, yung sa n-bit naman means, pwede yung maging 8-bit, 16-bit, 32-bit, and so on. So, that is all for the explanation. It's just quick. So, that is all. Thank you.
That is all.